Hello, everyone. I'm Shiv. Let's go deep into the NSP, if you will, the Nile Service Block. But it all starts with the purpose-built hardware. I think Suresh spoke to that. Our goal really here is not to sell hardware, right? We're not selling you an AP. So if you look at our APs, they're all 4x4:4. Today we have three types of APs. We've got a Wi-Fi 6 indoor AP, a Wi-Fi 6 outdoor AP, and a Wi-Fi 6E indoor AP. And we have a Wi-Fi 7 direction antenna ruggedized AP that's going to be coming out. And we also have a Wi-Fi 7 indoor AP coming out. But the key thing is it's one SKU, meaning that it's just 4x4:4. You don't have a 2x2 version or 1x1 version. The idea really here is to give the Cadillacs of Cadillac to all our customers. They all do up to 5 Gbps uplinks. We've got a Bluetooth built into it. So we make sure that this is the top-notch hardware that's out there. On access switches, which is where the APs plug into, right? We've got a 48-port switch. We basically got multi-gigs, so 100 all the way to 5 Gbps on every single wired port. We've got PoE++ on every single wired port as well. And they get uplink into a distribution switch.
You guys are still very young, and I'm sort of curious what your plans are for lifecycle managing out, in particular Wi-Fi APs, Wi-Fi 6 to 60 to 7. Are you if somebody needs a new AP and you're no longer making Wi-Fi 6 APs and you send them a Wi-Fi 7 AP, it's going to create clumping and all of that, right? How do customers make sure that they keep the latest hardware as you make new products?
Absolutely. You want to take that, Suresh?
Sure, Sam. So this goes back into, our contracts. So when we talk to the customers, we look at, probably 3 to 5 years contract terms. So when we continue to make sure that if you have Wi-Fi 6 or 6, we continue to make sure if you have to replace one or two APs, we know, like yesterday, there was a clear article saying that you cannot mix some of these things, and we understand. So we continue to keep some of that, but we move on from 6 to 60 to 7. We do not try to continue to sell Wi-Fi 6 when there is a Wi-Fi 7. It's only needed to support the existing customers. And then when that contract expires, or when we work with the customers and figure out how many devices are capable of Wi-Fi 7, what's the capacity on the network, what kind of constraints you have on the network. So even during the contract time, if needed, we will upgrade the hardware too.
And those are one-off conversations, or are those planned through the life of the contract?
So we have a customer success manager who works with the customer on a regular basis. It's an ongoing conversations with the customers.
Thank you.
Awesome. Thank you, Suresh. So on the access switches, what you'll see is you can kind of stack them. They look like a stack. They're not a stack. They're a ring. And we'll talk a bit more about those details. And you can actually easily scale up and down. And these connect into a distribution switch. And these distribution switches are aggregating all those access switches. Now, the key thing to note here is, up here, if you see the distribution switch is connected to the upstream router and firewall. And as Suresh said, we have single architecture, but we can have multiple topologies. So if you have a small office suite, you don't need a distribution switch. You can just have an access switch that connects to the upstream router firewall. It could even be that internet gateway that he was talking about, the edge service. But the idea really here is to basically make it as simple turnkey as possible. So whether it's the access switch or the distribution switch, they're identical. The code is the same. You can actually plug in your 10 gig servers into that distribution switch if you want client access. And then finally, that distribution switch also has something called as a headend, which is basically the brains of the NSB. The headend can be virtualized in an access switch if it's a small deployment. It can be virtualized inside a distribution switch, or it can be a physical appliance when we talk about that 30K capacity that we're going up into. The key thing here is we also have physical sensors that are used to monitor the NSP, right? So with 24/7 monitoring the NSP, think of them as dedicated clients that are plugged into the wall, or the AP's third radio, which is a dedicated sensor that's monitoring the network. And the beauty is it's an outside-in view, which means you can do that simple test, that ping test from your laptop connected to the NSP and validate whether what we are showing you minute by minute is the availability, coverage, and capacity of the network.
Can we talk more about the sensors? What are they doing? Is it synthetic testing? Is it?
Absolutely. So we've got three types of sensors. We've got a physical sensor, the one that you see there. We've got a third radio sensor because you cannot plug these sensors everywhere. So this sensor and the third radio sensor are identical. All they're doing is a ping every 12 seconds to validate the network. They're looking at the beacon reports, sending to the cloud so that we can do the coverage and capacity planning. And then the AP's third radio sensor also does widths and whips. So that's all fully automated. And then the third sensor that we have is built into the switches. And this sensor is doing some of the synthetic tests, right? So we can actually do a radius transaction on UDP 1812 with the credentials that you provide every single minute. We can do a DHCP transaction. We can do a DNS transaction. And then there are top 10 apps for the site, which we do an HTTPS transaction with.
And is your sensor in the AP, is it actually doing a .11 association to another AP, or is it doing that test from within inside the AP's network perspective?
The neighboring AP.
The neighboring AP.
Yes, it does not connect to the same AP.
So it associates, gets an IP address, and
exactly.
Okay.
And you will see that in the next slide on what why we have different subnets.
Are all 3 sensors deployed in an environment? Do you make a decision, or does the end user make that decision?
Right. So the APs obviously have a dedicated sensor. They're turned on automatically. The sensor in the switch is obviously always turned on because the switch is always there, whether it's an access switch or distribution switch, it does not matter. And the physical sensor is where there is some determination. We have some guidance, try and put in the perimeter of the building, in conference rooms, in locations where, you don't want to put in a dorm room, for example, right? Someone's going to kick it off. So yes.
Do you ever see or foresee not having physical sensors and just completely leveraging AI to do everything?
Yes. So we do have installations where there's no physical sensor at all, just because you can't place them. But then the AP's built-in radio does that physical sensing.
And what do you think about putting a sensor like on a device?
Yeah, that's something.
Sure. Well, I think that question comes up. Frankly, we talked to a lot of IT teams. It's another nightmare. There's so many agents on your laptops. There's another nightmare for one is the operation side of it. Second is that could be your security gap, frankly. So many CISOs, they hate adding another agent for that. But instead, we're able to capture a lot of information using the sensor data and the data that we receive from the clients. We're able to access a lot of that information. So, and also, even though we may not have at a particular customer site, but we have the sensors across all our customer sites, we're able to gather that data to understand the client behavior and continue to fine tune it.
Perfect. Awesome. Thank you, Suresh.
Are you aggregating that sensor data across your clients then and able to do things like regional information? Hey, we know these offices from these different clients are in these areas. There's a problem upstream, potentially regionally. Are you doing that aggregation across multiple clients right now, or is it just single client, single site?
So a few things, right? One is the data the sensor collects. That input can go into multiple places, like channel planning is one thing where we do. If something is down, those are all real tests that are happening in every single environment. So for example, if you have a DHCP server that's global, if you cannot reach that DHCP server from one site, does not mean the DHCP is down, right? So we actually have that data coming from every single site to kind of show you that, hey, that DHCP server is accessible or not. So there are two tests we do. One is that DHCP server itself available or not, right, from transaction perspective. And the second is to show you the view, is it accessible from the site, right? So, but we do real-time tests every single minute from every single site and show you the data from every single site. Right.
Sure. I think to answer your question about aggregating across the tenants, right? So the idea is yes. That's how we do a lot of channel planning simulations in the background. So, like universities may have certain type of environment, distribution centers may have different type of environments, right? As the warehouses, the stock goes up and down. So we do simulate those kind of information, per deployment type, for lack of a better word, right? And then apply those logic based on the deployment type.
So one question that we always get, hey, you're a cloud company, what happens if the internet goes down? Does everything go down? The answer is no, right? Once you set the network up, if you have an on-prem radius, on-prem DHCP, everything just works fine. New clients come in, they connect, they can pass traffic. So nothing goes down. You only lose that control and visibility from the cloud, but the NSP itself stays up. The next thing is wireless redundancy. I mean, we do not want to escape Ekahau, right, or Hamina. We want to do a proper design. We want to make sure we can, pull all that design into Nile. And that's where, we were talking about the digital twin is because we have all that information. And then in an automated fashion, we try and figure out a salt and pepper design, meaning two neighboring APs should be on two separate switches, right? We don't want them to be the same switch. That way, when you do upgrades, we at least have that coverage. And if something goes wrong, that AP can at least cover the entire area. And then wired redundancy, again, that's the whole ring. So if you look at our switches, you have a DAC cable in the back, might look like a stack. It's not. It's just a ring running OSPF. That way, if one switch goes down, we can easily work around that issue and have multiple paths out of a closet, if you will. We also run OSPF on the uplinks. So the uplinks can go up to 100 gigabits per second on our distribution switches. So every distribution switch can do 2 uplinks. So we can have a total of 4 uplinks from an NSP. It's an active mode. And the beauty is you don't have to set OSPF on the Nile side. You set it on your router and your firewall. Through Hello Messages, we learn, we self-configure ourselves, and that's how the network comes out. And we'll double click on that whole setup in a minute. So very quickly, I want to touch base on that L3 fabric we talked about, right? Why did we go about doing the L3 fabric? So as you know, VLANs were really designed to control broadcast storms, but they got morphed into segmentation, right? And then the whole policy, downloadable user roles, all these things came along with it. But if you look at it, by default, if you have a VLAN on a switch, it's already bridged, right? Unless you start doing private VLANs or doing IP access lists, which very, very few customers really do. So it's pretty much wide open. And that basically enables lateral movement of traffic. But if you really want to campus zero trust, you need to start, locking all that stuff down. So loops, for example, we don't even have STP because we don't have that traffic that goes through. within the network. By default, every port is secured, and we'll get into more details on how we do that. If you look at identity, there's no identity really tied to a VLAN. Yes, you can say this VLAN is for my employees, but once you get on that network, we just go anywhere and everywhere, right? If you can get on that network by just plugging into a wired port. But again, we bring identity on every single wireless LAN as well as on every single wired port, and we'll chat about that in more detail. The more important thing is once you're on the network and you're authenticated, how do you apply policies? Do you apply it based on subnets, or can you do that based on true identity? And again, we touch based on what we do on microsegmentation in a few slides. So very quickly, whether it's a 2 access switches connected to 10 APs in a small office suite, or whether it's a large campus where you have distribution switches, multiple rings of access switches coming into distribution switch, the effort it takes to really bring up the network is the same, right? So we really don't have any config on our access point and switches that truly beep and scan. The way we do that is, we have a mobile app, and the installers are empowered to use that mobile app. Customers like yourself could also use that. But what we're really asking you is for an uplink IP, 1 for this distribution switch, uplink IP 2 for that distribution switch, and a couple of subnets. That's all. Once you give us that information, the entire network, whether it's again 2 switches and 10 APs, or 500 APs with 100 switches and distribution switches, it's all the same. So what happens is that config gets pushed through Bluetooth. Bluetooth is only turned on in 2 scenarios. One is factory default state, and the second is if something crashes on that device, right? Because we don't have any console ports, we don't have any SSH telnet into these devices. So that's the only time Bluetooth is turned on. You need to have a job, you need to have a username, password. So it's completely locked down from that perspective that no one can just log in and grab the details. So
is there a way to force that Bluetooth on?
Yes.
Manually on the box?
There is, yes. If need be, we can certainly, assuming it's online, we can force that. And not only that, the beauty is sometimes remote site and you don't even have the mobile app available. So we can actually turn the Bluetooth on AP1 to connect to AP2 if AP2 crashed, right? And then pull that last breath of logs if need be.
But if there's a stuck state of some kind,
Bluetooth will automatically turn on.
But it has to recognize that there is a stuck state.
Yes.
For the Bluetooth.
Yes. So that's how it's been designed. Anytime there's a crash or anything that's stuck, and we can't get to it, it is designed to basically turn Bluetooth on. So for example, if the internet goes down and it does not come back up in a certain time, we might turn on Bluetooth on the gateways, right? And obviously that is physical access that's needed to a closet. Great. So once that is done, what we do is we have the NSB gateways. Gateway is nothing but a role. In this case, the distribution switch is talking to that edge. So it is a gateway. It could be the access switch that could be acting as a gateway. But gateway is a device that connects to the upstream router or firewall. They're running in active mode. We basically have them being the default gateway for all the Nile elements. So all the traffic is going to go to them and they're going to route it out. And since OSPF is configured, all the traffic is advertised to the upstream router and firewall. And that configuration is coming from the firewall or the router. Whatever you set up from a config standpoint in a firewall router, we learn that through hello messages and configure ourselves. Yes.
In this model, are you guys also providing that edge and firewall?
We have built something called the edge service, which will basically be that edge, and that would become the entire NSB connecting to the internet. So you could have a couple of uplinks and a disaster recovery, like a cradle point that could connect.
Okay, because you made it sound like it was something that the end user is providing. And
so both options are available. So if it's a large campus, we would connect to your existing router or firewall, right? You may not want something from us. If you're a small, mid-market customer segment, you probably just want to replace the entire stack with Nile, and that is something we have as well. Now, the key thing here is once we set all this stuff up and we push that config, there were 2 subnets we asked you for. We asked you for an NSB subnet, which is for the APs and the switches, and we asked you for a sensor subnet. We automatically start running a DHCP server in that distribution switch or access switch if it's connected upstream. And this DHCP server is only used for Nile elements. So you're not really using this for your client devices. We have the DHCP service in the cloud that you could leverage if you want to use Nile, or you could use your own DHCP. But this one is turned on automatically. We do not configure it. You do not configure it. All you do is give us subnets. And once you give us those subnets, we basically start advertising those IP addresses. So as an AP or a switch plugs in, it basically gets an IP. And the sensor subnet is different. So that AP actually has 2 IPs, one that it gets on its physical wired interface, and the sensor also gets an IP address which it can connect to, to a separate AP. And that's the reason we have a separate sensor subnet, because we like to treat it like a client. All right. So this is getting into a bit more details. How does this all come together? I think we are very familiar with what the controller-based architecture is from an AP perspective. You never ever configure VLANs on those APs. You don't configure SSIDs on those APs, right? You literally just plug them to the network. They discover the controller. The controller then, pushes the config, whatever is needed. They advertise the beacon. When the client traffic comes in, all they do is just send it through that tunnel, CAPWAP or IPsec to the controller, right? That's how it is. So obviously we do the exact same thing with the APs, but we've extended that to the access switch. So every wired port is creating a tunnel to the head end, just like the AP. And that is why you do not need to have a VLAN on that switch. That is why you do not need to have any configuration on that switch, because all the traffic from that port directly gets tunneled into the head end, right? So if I have two devices on the same subnet, that traffic is all going to go to the head end, and the head end can decide what to do. And that's how we can implement zero trust, because you don't need to configure that port. Now, sure, in some cases you want a lock to port because you have a phone and it's tied to E911. You have the ability to do a port level config, but by default, there is no port level config. There is no segment, there is no VLAN, there is no information that the switch knows. If that switch goes bad, you just chuck it out, put a new switch, and you're good to go, because it's not doing nothing but just creating those tunnels directly into that DS. So whether it's a wireless client that hits the AP pushes into the tunnel, the NVGRE tunnel. If it's a wired client, it goes to the switch, it puts it to the tunnel, and it goes through. And at the head end, you decide, what should I do? I'm going to talk to Radius and identify the identity, or I'm going to basically go and look at MACauth and look at the identity and put it on the right segment. So that is why no VLANs exist within the Nile network.
And how are you creating that tunnel? Is it proprietary or is it a standard?
It's automatic NVGRE. We just, as soon as the code comes up, it discovers the controller, gets an IP, it will build that tunnel.
And how much sort of capacity can those head ends cope with in terms of throughput?
So throughput, it depends, whether it's a virtual head end or whether it's a physical head end. I don't know the numbers too. Does anyone know the numbers for the capacity?
Sure. So we go up to 25 gigabits per second throughput. So we have the controllers depending. So this is where, when we do the site survey, we understand the requirements, scale and performance. And based on that, the network is automatically designed with the appropriate capacity.
So you'll put in multiple head ends, will you, if you need more than 25?
No, so typically you have only two head ends, as they showed, the primary, active, and standby, and each one can handle up to 25 gigabits per second throughput. If you need more than that, you can have multiple Nile Service Blocks. These are like Lego blocks, and you can interconnect them as needed using a next level. But you can have multiple Nile Service Blocks to support larger scale. So today we can go up to 30,000 clients, and we're going to increase it. But if you need beyond that, you can deploy multiple of them.
You'd deploy multiple head ends, would you, to get
multiple Nile Service Blocks?
Oh, okay.
Yeah, that's right.
And what about the other scenario where you would only need like a couple of APs per site? Do you have to deploy the entire?
So as I said, we have a built-in head end. These head ends are typically built into our switches. So you don't even realize that you have a separate head end.
Yeah,
so like a switch
right here, the virtual head end, it can be inside the access switch.
Okay.
And if you're even doing the internet gateway functionality, that is also built in the access switch. So you might just have two, physical hardware appliances, right? Which is what you'll see here, or a 16-port switch. We have a 16-port variant of this, and you might have two APs. That's it.
Yeah, like a PoE switch and an AP.
Everything enabled in one.
And I think I missed it, but the tunnel for the AP, does it just get set up with one head end? Is there a backup tunnel that goes to the other head end, or is it a stateful type of failure?
So right now, this is an active standby, right? And the APs do have a standby tunnel, and yes, they would do that.
From the endpoint perspective, because I know other manufacturers I'm not going to say they do what you do, but the other manufacturers, they're doing kind of LAN-based micro-segmentation, throw a /32 at the endpoint because they don't own the full network stack.
Right.
So they can't control it other ways. What is the client thing during this?
So client, this can be on a /16 or /32, we don't care, but we treat every client as though it is a /32.
Okay.
Right. So it is isolated no matter whether you're in the same subnet or different subnets. We just do not allow any traffic by default. You have to put a policy to enable that. So if you want employee and employee to talk to each other, a policy has to be created. Yes.
And quickly to add on to Royal's question, so it's a stateful switchover. If you ever need to do it, it's a stateful switchover.
And then what were the limitations again for the?
So we can go up to 30,000 clients, and we can go up to 25 gigabits per second.
Okay.
And how do you interconnect? So if I need to deploy multiple Nile service blocks to get the capacity, do you interconnect at the head end side, or are you expecting it to go up through the client's edge and then back in?
Edge.
Yeah.
So I'm going to have to build capacity on my firewalls to port capacity and all the rest, or create
Router.
A core block outside of your core block
That's
that I manage and run that then interconnects to my edge. Okay.
Yeah. All right. What we spoke about was the setup for Nile, right, which is almost zero touch. When I say not zero touch, zero config, right? We'll talk about zero touch in a minute. That is what it takes to bring the network up. It's like that Uber car that's waiting for you, right? But you still have, control over, how you're going to, what passengers are you going to bring along, how many suitcases, what your destination is. And that's what we like to call the context, setup. This is all done through Nile portal, so you will set it up. What we're trying to get to is we want to make it as intuitive as possible without the need for groups and profiles and trying to figure out which AP gets which group, which profile. As you know, that's still cumbersome. Licensing that's required. You have to claim a license. You have to, doing RMA, you have to figure out how to, unclaim that license. So with Nile, it starts with the customer telling us what service areas they want, right? Service areas starts with a site, a logical construct. So Santa Clara could be a site, if you will. In site, you could have multiple buildings. So this particular building could be an actual building in there with an address, a physical address. A building has a floor. And then on the floor, you can actually draw what we call a zone, right? So here I'm drawing a zone. I'm calling it the guest zone. And this is what service areas are. So it's very straightforward. Just create a simple site, building floor, and a zone on that. Now, once you do that, all the other constructs from a setup perspective are tied to that service area. So I can create a DHCP server and say this DHCP server caters to site 1. Right? Very logical, right? I have a DHCP server in Bangalore. I have a DHCP server here in San Jose. I've got, one in London. So you just create your resources, if you will, and map them to a geo. You can easily create one single DHCP server and map it to all geos if you have a global DHCP server. Same thing with SSIDs. You decide where do you want those SSIDs. I want my employee SSIDs at all my sites, right? I want IoT only in site A in this case. Now, once you basically do that, when you plug an AP in, depending on where that AP is, or head end or switch, because we know the XY, when we do the install, we know exactly where this AP is going. So if you install this AP on floor 1, which is outside that guest zone, it will inherit the employee SSID and the IoT SSID automatically. The beauty is this AP dies, you just go there, you click on the floor plan in the mobile app, you deactivate that AP, take a new AP, plug it in, and you're good to go. There's no claiming licenses, there is no pushing profiles, right? There is no group information that you need. It is as simple as just knowing where you want to install that, which is already pre-built as part of the mobile app. And that's where the digital twin is very critical, because we need to know exactly where every single device is, whether it's a switch, head-end, distribution switch, or an AP. So in this example, the AP2 and AP4 are going to have the guest SSID because they are in that zone. Their XY falls in the zone that you had created on that floor plan, and it automatically inherits that config based on that. So we basically land up with no profiles, no groups, and it's very, very straightforward. I'll quickly touch on key capabilities, and then I'll hand it over to Avinash. No, who's going next? Suresh is going next. And we can spend some more time talking about this, but we wanted to highlight some of the automation that's already built into Nile, right? So one is we obviously have deep packet inspection, multiple protocols and applications is what we can figure out. Not only that, based on that information, we can do automated QoS, right? So we know this is FaceTime audio, we know this is FaceTime video, we know this is Zoom audio, Zoom video, and we can essentially mark the packets with the right DSCP. So when it hits the router or the firewall, those markings are in place, right?
Is that deep packet inspection full stack, whether it's on the AP or switch or at your gateway?
It's all on the head end.
All on the head end.
Because all the traffic just comes to the head end, and that's where we apply the policies.
Okay.
Yes. A lot of people ask us, hey, you're layer 3. What about layer 2, right? What about that passive client? What about multicast? What about broadcast? By default, everything is blocked. And in the portal, you'll actually see a list of every broadcast traffic on your network. You'll see every single multicast on the network, and you can allow them or disallow that, right? When it comes to, IGMP snooping, we can actually completely in an automated fashion, snoop those packets and try and connect all the devices without needing, 1,000 pages of config. Yes, sir.
Oh, I was just going to see if you'd talk a bit about MDNS.
Yes. So MDNS discovery is automated across segments, and it's also location aware, which means that if there's an AirPlay device in building A, that AirPlay device is not going to show up in building B. So it'll be context aware based on where you are, and the advertisement would be available on every segment within that network. But when you connect to it, it is basically an L3 connection, right? That's where the policy comes into play. So even though you can see it, does not mean you can necessarily connect to it if your admin has not permitted that. Yeah.
Well, quick question about the deep packet inspection. Is that something that the customers have access to?
So a couple of things, but first of all, we have a lot of content. So can we hold off on some of the questions till the end of the session? And then we'll definitely go into the deep packet inspection, the capabilities, and like if they have private applications, how would they get access to that information so that you can do the quality of service?